Alright, now we're going to do the second ACSL problem from the third quiz from 2015-2016. The first step, of course, is always to read the problem very carefully. We're looking for how many ordered triplets make the following Boolean expression false. That's going to come in handy later, but first, as always, we're going to simplify the expression, so we're not dealing with a lot of unnecessary terms later on. The first step is to use the De Morgan's rule on this term here and this term here. Using that rule, we get not A plus not B times A plus not BC plus not A times not B plus not C plus A. Alright, now we're going to distribute our terms so that we can keep simplifying. So that becomes not AA plus not A, not B, C plus not B, A plus not B, and it would be not B, not B, C, but we can cancel out two not B's since that's the same thing, and we get not B, C plus not A, not B plus not A, not C plus not A, A. Alright, now we're going to look back to our special rules for Boolean algebra, and we know that something can't both be itself and not itself. So this first term and this last term are both 0, and we can cancel them out. So now this expression is not A, not B, C plus not B, A plus not B, C plus not A, not B plus not A, not C. Alright, now to keep simplifying, we're going to factor out common terms. We see that the first term here and this term over here both contain a, not B in them. So we're going to factor that out as we would in our math class, and we get not A, not B times C plus 1 plus not BA plus not B, C plus not A, not C. Alright, now looking back to our special rules, we know that anything or 1 is always going to be true. So that expression is just not A, not B. And then just rewriting the rest of it, not BA plus not BC plus not A, not C. Okay, now we're going to factor out common terms again. And we see that a not B this time is in 3 out of all of these terms. So we're going to factor that out, and we get B not times A, not A plus C plus not A, not C. Again, another special rule was that anything or the opposite of it, so not A or A, is always just going to be 1 as well. So then this becomes not B times 1 plus C plus not A, not C. And as we know from before, anything or 1 is 1. So this becomes not B plus not A, not C. Alright, now this is the fully simplified expression that we're going to work with now using the Broner method to find how many ordered triplets make it false. But we're going to work with this expression so we don't have to deal with a ton of unnecessary terms. Alright, as we showed before, the Boolean expression simplifies out to not B plus not A, not C. And now we're going to work with this and make our table. If you're confused about what just happened, watch Charlie's first video on the Broner method. Now we're going to find our terms that aren't already on the truth table and write out columns for them. First one being not A. Now not A is true whenever A is false, so I just look over the first column and make 1 appear when 0 is there and vice versa. The same thing is true for not B and not C, referencing the columns B and C respectively. Alright, now we're going to start creating our terms. So we already have a not B column, and now we're going to make our not A, not C column. Not A, not C is true when both not A and not C are true, or in other terms, when both A and C are false. Now we're going to find the values of the whole simplified expression, not B plus not A, not C. And this is going to be true when either the not B column is true or the not A, not C column is true. And this is the truth table it results. So now looking back at the question, we're looking for how many ordered triples make this Boolean expression false. So we're looking in the last column to see how many zeros there are. And we see that there are 1, 2, 3 zeros. So 3 is going to be your final answer for this question.